Hello, everyone, and welcome to today's SANS webcast, Threat Hunting Through Log Analysis in AWS. My name is Carol Auth of SANS. Today's featured speaker is Shaun McCullough, SANS Community Instructor. He will be moderating today's webcast. If during the webcast you have any questions for our presenter, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to Shaun.
Thank you, Carol. Thank you very much. And I want to thank you all those that are participating today. She said, my name is Shaun McCullough. I'm one of the instructors for Security 545, which is all about cloud security and orchestration and architecture. But I'm working on a new class that will be called 541, and it's all focused on threat hunting inside of AWS. So today's talk really pulls from the information that we're working on in this new class. Okay, so just about me. I've been in security engineering and software engineering, but both together for 20-something years. Hate to admit it sometimes when I say that, but I love the fact that in a cloud environment, we can use software capabilities or scripting or Python and other programming languages and things like software control and testing and all that kind of stuff. And we can bring that to bear in our architecture, infrastructure, and our virtual machines and our networking and in our security. I've done some talks before in SANS about infrastructure as code and how we can automate the security process. But today I really want to talk about how we can do threat hunting in AWS. And so we're going to look at what is threat hunting, but what are the tools that Amazon has in place that gets you access to data, how we could use that data to detect something that's going on inside of our environment, and then maybe some architectural conversations at the very end about what we can do to improve our environment. All right, so especially our environment for threat hunting. So the first thing to do is we got to talk about what is threat hunting. Threat hunting definition: proactive evaluation of your infrastructure to try and figure out if something bad is happening. And I look at threat hunting different than maybe looking at your security controls to see if they're on. That to me, that's not threat hunting. That's a great thing to do. We should do that. If you have your team that's monitoring the security environment suddenly gets an alert that there's malware on a host, and you go and you clean the malware. That's awesome. We got to do that. I wouldn't consider that hunting. I look at hunting, and especially threat hunting, as really saying, okay, there are threats out there that I might be vulnerable to. I'm going to go see if I can see an attacker using those threats in my environment. Or maybe there's something weird going on. I don't think it doesn't say that there's an attack, but I'm going to go investigate because it looks like it could be X, Y, or Z. We use the word threat before the hunting. We could just talk about security hunting, but threat is really kind of driving where we focus our time and attention. We're going to focus by looking at what are the things that people are doing inside of my environment, or I should just rephrase that. What are the things people doing in environments like me? And can I detect that those bad activities are happening? And if I can detect them, is there a way that I can stop it, or maybe I can mitigate it so it doesn't keep happening? That's our goal. A lot of times when we're doing threat hunting, we're digging through logs. We gotta dig through logs. We gotta look through telemetry data and try and pull out nuggets from those logs. And that's really the hard part. Okay. Today we're going to spend a lot of time figuring out what those logs look like and what we're looking for. I'm not going to go through an exhaustive, here are all the threats against an environment. We just don't have time. But I definitely want to give you some places that you can go look to see where your threats are. All right, so learning about threats against the cloud environment. I would say SANS broadcasts and SANS classes and papers, they do a great job of identifying here are threats and how you would mitigate them. Some of the classes are very much here's threats and here's how you could do them in your environment to test your blue team. Those are fun. Twitter is a great place. Like, go and follow people that are focusing on the security of cloud environments. There are people that's all they do, and they really identify some really interesting things. papers, research, Google, there's a lot of stuff. I like also looking at MITRE ATT&CK. Now, if you've heard any talk in the last couple of years, you've probably heard of MITRE ATT&CK. This is a framework that the company MITRE put together, and it's really designed to give us a really great way of categorizing and communicating threats, and especially esoteric stuff like IP domains and hashes. We got it. We know how to communicate that. But when you look at stuff like some, credential harvesting, that may have different connotations to different people, the cloud or the attack matrix really tries to bring some order to that chaos. So if you look on the screen here, you've got the gray bar across the top. Those are the tactics. And the tactics, I always look at them as these are the things the bad guy wants to do to you. So the bad guy wants to gain initial access. They want persistence or discovery or credential access. Going down the list are the techniques they may use to do that. And if you click in each one of those boxes, you'll get a lot more detail. MITRE over the last probably year, maybe a little more, has been building framework matrices specifically for different environments. So I'm showing on the screen here the cloud one. There's one for Linux, there's one for enterprise, one for Windows, one for your security control systems, and they're very hyper focused on the kinds of attacks that they have seen against these environments. And I won't show it here today, but it's great when you click into these. Not only it tells you their information that they've put on there, that MITRE has put in there, but they have a list at the bottom of all of the publicly available reports that describe that particular attack. So I love that kind of stuff. So here's the cloud matrix. We will look at this later. The other thing I really like, and I push on organizations I work with, is looking at the OWASP top 10. This is a top 10, I don't want to say list, because list kind of seems like just a bunch of words, but this is detailed, packed information about the top 10 techniques attackers use to gain access to web applications or web services. All right, we're talking about the cloud. Well, why do I care about web services? Well, if you're running stuff in the cloud, it's mostly going to be web stuff. I mean, that's kind of what we do. The web is, or the cloud is really built as a web application itself. And so it's really good about running web applications. So even if you're running web servers that have like a front end with the people enter data, like we'd normally think of a web service, but there's also going to be back-end computational systems that have web front ends. So we really got to look at these web techniques. And so I would definitely encourage you to go look at that OWASP top 10. And I know it says 2017. There's a 2019, but it's similar information. It just didn't print out as well. But anyways, what we're going to do is through this talk, I'm actually going to grab 3 different techniques that are in the MITRE ATT&CK and also OWASP, and we'll walk through them a little bit. All right, big part of the question is, I need logs in order to do threat hunting. Where am I going to get the logs? I kind of break down into 3 basic environments, or I'm sorry, 3 basic ways in which we might get logs, or from 3 different places, I guess. It's probably a better way of saying it. First one is from your web or your AWS environment itself. When you are interacting with Amazon Web Services, when you're in the console and you're creating EC2s, or you're using the CLI, or you're writing bot03 code, you are interacting with the Amazon management plane. And Amazon tracks all that information and gives it back to you in a service called CloudTrail. CloudTrail looks at it, takes a history of all your actions that you take in AWS with the AWS management services, and gives you the ability to pull that stuff back, evaluate it, filter on it, print it. All right, a little under the hood on what we're talking about. All of our interactions with the Amazon Web Services, such as in the console, if I click on the buttons to create a new EC2, I'm really generating REST calls to a server. So if I were to run EC2 describe instances, and I will tell you that we are going to be talking very specifically Amazon here, and we'll be using things from the console and things like that, or the web CLI. When you use that web CLI and you type out AWS EC2 describe instances, what your goal is to get a list of all of the EC2 instances that are running in your environment. You can see that what it's actually doing, it's making a post call to this server. So I'm on the East Coast, so I'm using US East 2, to the EC2 server, whole bunch of information. And then I'm giving it some data. The action is going to be describe instances. That is the task I'm giving the server. A little bit of version information. And what I'm going to get in return is a giant XML. And the AWS CLI takes an XML, generates some pretty output for us. It is a REST call. That is what we were doing to this service. That REST call was tracked in CloudTrail. So if you go to the CloudTrail service, which I'll show in a demo, and you were to go look at a describe instances, it's going to print out this nice table right here, and it's going to give you great information. It's going to give you, like, well, the access key is interesting. The source IP, where did this come from? This can be very important as we're doing our threat hunting. Who made this call to the EC2 server? The username, so this is my username. I ran this command, and the region and some other nice stuff. It then allows you to get all of this detail about the request. This is in a JSON file. All of the CloudTrail records are JSON, okay? So it's a single JSON object. So you're gonna have to parse that data somehow. I'm gonna show you how to do that. You got the information about which account it was, and then the role that was used to make this call. So how were you granted privilege to do this? So you can get a ton of information about what's going on. One of the nice things about doing things inside of Amazon is you are tracking all of those calls through the API. And so you're getting copies of it in CloudTrail. And since CloudTrail already knows the format of the data that's coming back, it makes it a little bit easier for you to query. All right, some specifics about CloudTrail. CloudTrail does record your API calls. Not all of them. There are some edge cases, which it does not. And by default, it stores this stuff for 90 days. But you can go to CloudTrail and you can add some configurations. You can create something called a trail, which I realize that we're saying the service is CloudTrail and you're creating a trail. It's confusing, I know. But you can create a trail that says, hey, API calls, I want to store in this S3 bucket over here. Okay? So I realize my hand's off screen. This S3 bucket over here. Or maybe I have another CloudTrail that's for somebody else and I want to store it over here. So you can pick the S3 bucket you want to store the data to. The data that's being stored is JSON. Oh, and you're not getting the results of my describe instances, not at all. What you're just getting is the information about the query, whether it's successful, who did it, by when, all that kind of stuff, but not the results. So you don't have that information. And then the data stored in JSON, you'll have to extract it, translate it, manipulate it, do all that kind of stuff. The logs are also accessible, not just through the web click, click, click kind of thing, but you can use the CLI to query CloudTrail and get those logs to come back. Some limitations, only 5 trails per account per region. Oh, so that means you're not creating like a ton of different trails. You're gonna do maybe one for your security team, maybe one for your ops team, maybe a CloudTrail that's focused on a very specific S3 bucket that's maybe a little scary, I don't know. But you're not gonna have a ton of them. You're only gonna have 5 per region. And then there's a little bit of a delay for the stuff to get to CloudTrail. So for you to be able to query an API, it could take up to 15 minutes to get that API call. We're not talking about real-time launching of some kind of Lambda code based off of it. You'll have to use other tooling for that, which I'll talk about. All right, so that's CloudTrail. What can we do with CloudTrail? Let's look at a particular attack, and we're gonna use the cloud matrix here for MITRE. Specifically, I wanna look at cloud service discovery. If I click this at cloud service discovery, then I'm gonna get this detail information. I'm not expecting you to read this detail information, but the detail information can tell us things like, which platforms this works on, what permissions they need in order to do this, a detailed description, there's mitigations, there's detections, and then lower on this list, which you can't see here, there is some links to reports of people or attackers or researchers who have used this in an actual attack. All right, In general, what is cloud service discovery? Imagine you're an attacker and you have gained access to a virtual machine, an EC2, and that virtual machine was running some kind of code that gave you a shell access to it, a web shell, whatever. Once you're on there, you don't really know what you have access to. You kind of have to figure out what's in this environment. So you're going to start doing things like list all my S3 buckets, identify all the users that is in this group or is this environment. What are the groups? What are privileges that I have access to? Parameter store. What is everything in parameter store that this EC2 has the privilege to go and look at? Because there might be some really cool secret information in there. These are all calls to the management infrastructure. These are all things that CloudTrail is going to log. So what we're going to do is we're going to look specifically at an attacker getting onto an EC2 or somebody getting credentials running list buckets. So we are interested in our hunting. We look at this cloud service discovery. We say, oh, you know, list buckets is probably something that they may want to do. I'm concerned about my buckets because I've got some really sensitive information. So let's figure out how we're going to use it. All right. So I'm going to go into the console. I'm going to pull up CloudTrail. And you can see in CloudTrail, I've got this event history. I don't have any trails here. I got event history. By default, I have 90 days of this. I can expand it, and you can see the information. I can see quickly who is the user, and I can see if there's an error code. Someone requested something, and it was denied because they didn't have privileges. All right, that's interesting. I also have the event name. So this is the command. We saw describe instances. Another one would be list buckets. So I'm going to look for everything that has list buckets. So this is all of the CloudTrail logs where someone tried to do a list buckets. And most of them are Shaun. There'll be some of the console, but you can see 2 EC2s. One of them was denied. This is very interesting. Okay, so one of them was denied. It is not usually, it is a good idea to make sure that your EC2s are only given permission to do what they need to do their job. All right. It's unlikely for you having code running on an EC2 that needs to list the name of all the buckets. You already tell your code which bucket to be using. If it's going to use a bucket, it doesn't need to list it. A human attacker might do a list buckets. So an attacker has gotten on this environment. They've tried to do a list buckets. It was denied. Your code probably did not do that, but an attacker might have. And so that's what we're looking for. And so you can look down in the details, and in the details, I've got a whole bunch of information about this command. I can see who made it. Oh, I can see the user agent. Hopefully you can see it on your screen. And that's the session issuer. But down below, I have things like the user agent string. That is telling me that the CLI was run, not bot03, not my code, but the Amazon CLI was run. That shouldn't happen on an unmanaged EC2 where there's code running. All right. So I can use this information to try and figure out that maybe something's happened. I should go and investigate that EC2. Now remember, in hunting, the first thing you look for is probably not the end result. It's just the lead. You know, you take that, it's like a detective in an old movie, right? You got the first lead, you go and figure out where that leads to. You go and investigate this EC2 and try and determine if someone has gotten onto it. CloudTrail is fine, it's great information, really good quick view of what's going on. But if you've got a week's worth of material and you're trying to dig through it, this could be painful. Let's use the CLI and see if we can use the CLI to look for that same information. So what I'm going to do right now is I'm going to run this command. And this is an Amazon CLI command that I'm running. It's called, CloudTrail lookup events, which is what I was doing before, really. And I'm giving some information. I'm giving it that an event name is equal to list buckets. So I'm looking for my list buckets. And then I'm only going to print out certain information, and there's an output table. So let's look at that again. I wanted to back it up so you can see it. So I'm printing out a table, and the table should look very much like what we saw before. You can see that there was that EC2 that was run the command. So now what I want to do is I want to pull out only the keys that have a username that starts with an EC2 or I dash. The problem is is our CloudTrail data that's very interesting is bundled up in this string. And so it is JSON. You can see CloudTrail events. There are some information like event ID, event name, read only. That is standard across all CloudTrail events. But the specifics of this CloudTrail event is inside of a string. And it's very hard for the CLI to be able to extract that information in query base of it. So we're going to need another tool. And so I like using JQ. So it's a JSON query tool that allows us to use the command line to extract, filter, and basically manipulate JSON data. So let's use that. All right. We'll clear out our screen. I'm going to run the same command, the list buckets, but this time I'm going to give it a JQ command. I'm going to pipe it to JQ, and I'm going to say, all right, JQ, only pull where the username starts with -I, right? And where the error code is access denied. I'm going to run a single command that says, give me all of the EC2s that try to do a list buckets, but was denied because it doesn't have the privileges. And now I can build that into it. I can run that like this. I can build it into a script. I can use other code if I want to do it over and over again. I've got a really nice way of extracting and manipulating the JSON data that's coming back from CloudTrail. Now, it looks a little complicated to start off with, but as you get used to it, you actually find that you can run these queries a little bit faster and manipulate that data pretty quickly. This is one way in which you can extract data from CloudTrail. All right. Something else I said before was about these trails. So they're log groups that allows you to say some specifics about what kind of CloudTrail data I want to save to a particular trail. I can specify a bucket I want to save this data to, so I can extract the buckets later. I can give a prefix for all that stored data. So if I have a security team has their own CloudTrail, I can prefix it with security. I can set encryption. I can give it a specific key that only the security team has access to. So now I have this data that's in here that's encrypted that only the security team has access to. I can have, every time a new log arrives, I can have an SNS notification. I don't see this happen very often because really, no matter how you specify your CloudTrail, you'll probably have a lot of data and you'll have just that SNS firing off a lot. When I say that, I mean SNS firing off that notifies a human that to go look at something. You might want to fire off and have a Lambda function go and evaluate this data to see if it's something it's concerned about. But having people respond to it, maybe not. You can also have different kinds of API calls. When I was showing you before, the default, it's just management data events or management events. There's also data events where it'll monitor an S3 bucket or even all your S3 buckets and will tell you if somebody writes to it or reads to it. This is really great if you've got an S3 bucket that data doesn't change a lot and it's very sensitive data. You want to make sure somebody's not writing it or reading to it. So you could put a lot of focus on that. And then there's something called Insight Events. Amazon has a CloudTrail Insights that will try and monitor some of this CloudTrail stuff and tell you if it sees something that looks odd. I haven't used it too much, to be honest with you. I find that most of the times people already know what they want to look for, and so they'll write the code to do it. But there's these other events. Okay, so that is CloudTrail. And that's a lot of the information that you're really going to get about what's happening in your environment. A lot of the real scary stuff that could happen in your cloud environment is through, or you can be detected through CloudTrail, but not everything. You might have network data you're worried about. So let's say you have an Nginx server, a web server with a web application behind it or something, and you're worried about an attacker attacking that environment and maybe trying to do a brute force attack against it or some kind of attack against the network environment. You're going to need network data. So Amazon has something called VPC flow logs. It's not a quote service, but it is a feature that lets you capture network traffic going across a virtualized network environment interface. So any of the network interfaces that Amazon has, you can pick to look for your flows. All right. Actually, there's not a whole lot to flow logs. I'm going to show you what one looks like, and you're going to get it and be like, all right, that's the data it has. It can capture the data going through an interface, and you can specify in a particular flow log, which the flow log will have a name that you can call it, and it'll store all the logs that are related to the configuration inside that environment or inside that workspace. And you can kind of say every network connection in that VPC, keep track of it. Or you can say in this particular subnet. So maybe you have an internet-facing subnet and you're really concerned about that network data. Or you can specify a very specific interface. And I find a lot of people, this is how they use VPC flow logs for troubleshooting, evaluation, remediation. They may specify a particular VPC and get all that data and put it in its own area. You can have VPC flow logs sent to either CloudWatch, which I'll talk in a little bit, or you can have it sent to an S3 bucket, which I'll show you real quick. Couple limitations. Not all of the data is captured. You're actually only getting metadata about the flow, about the conversation between the source and the destination. You're not getting the content. So if you have an SSH connection, you will see that there was an SSH connection, but you won't have the contents of it. Actually, you don't know it's an SSH connection. All you know is that it was port 22. That's really what you have. There's no investigation of the underlying application data. It's just, this is the network traffic. Also, Amazon decides what you can get. There are some things that it will not track. Like it does not look at any of your command calls to metadata service. It doesn't track that. If you do use something with Amazon's Windows update services, it won't track that network traffic. So, and there's a couple more, but that's the big ones. You also can't edit your flows. So if you say, hey, I've got this VPC and I want all my data to go into this S3 bucket, you can't edit and say, oh, I want now this S3 bucket. You have to delete the whole thing and delete the VPC flow log and start over, which you got to keep in mind, because if you want a year's worth of VPC flow logs and you decide to move to another direction of where S3 buckets, you got to keep that in mind. But all right, this is what a flow log looks like. We're not going to read all these numbers, and the numbers are kind of made up. You're going to get your account information, the interface it was at. I guess that's useful. If I look at that interface, I have no idea what I'm looking at, but that's the information it gives you. Your source, your destination, your source port and destination port. That's how I think it's SSH, because it's 22. I don't really know what data it is underneath it. I also get the number of packets. Remember, this is in a conversation, a TCP conversation that's being kind of said, okay, this is the entire conversation. There were 20 packets in there with 4,000 bytes. And so it tells you that information. You don't know what it was. Some start and end times, and then whether the network communication was rejected. Was there a failure? Was there a reset, basically? That is what you get by default. You can customize your VPC flow log to have additional information like your VPC ID, your subnet ID, your instance ID. That is great if you are trying to bring logs from maybe CloudTrail and VPC flow logs and you want to put them together. You need something between the two, and the instance ID would be the same between the two. So you could use that to coordinate the data and maybe pull the data together if there's a particular EC2 that you're worried about. But it would be harder to do with just the interface ID. You also get all the TCP flags, which means there's a whole bunch of TCP packets going back and forth with different flags. It'll just show you all the flags. Things like which region, AZ, all that kind of stuff. Anyways, you're going to get this network traffic that's going to give you kind of an idea of what kind of conversations are happening inside your Amazon environment between your instances. So how can we make use of it? Let's go back to our old trusty MITRE ATT&CK cloud matrix. We'll look at one particular, and I would say the cloud matrix historically has been very Windows focused and host-based focused. So there's not as many network attacks that can be derived from the matrix, but there are things like brute force. So let's look at a brute force attack. MITRE had just recently come out with something called sub techniques. So for all of you out there that are using Amazon MITRE right now, and you've been doing attack, the sub techniques really allows you to break up Like instead of just saying brute force, there are different types of brute force that might look different in your environment. So they're broken into sub-techniques. A brute force attack is really, I don't have the password. Maybe I have a username, maybe I don't. And I'm an attacker, and I'm going to just keep trying different usernames and passwords until I can gain access to the server. We're going to look for an SSH attack. So someone is attempting to SSH, they're throwing usernames and passwords. I'm interested in that kind of brute force attack. So let's see how we'll do VPC flow logs. So I've already created the VPC flow log, but I just want to show you what it looks like. I can pull up a VPC. And I'll show you what the creation screen looks like. So I can say whether I'll accept or reject or all data. So maybe I only care about the rejections. I can specify my bucket I want, and this is where I can customize the format. So I can make the format of the data look any way I want. Here's my VPC, here's my S3 bucket. So all of the traffic in that VPC is going to this particular bucket. Right, I click in, click in, click in. All right, and now I have this thing, this file, gzip file. All right, I'm going to download the gzip file, and I'm going to open it. And that's what it looks like. I have a blank line on there just to make it readable. But that's it. It's a CSV file that's zipped up and dumped in the S3 bucket. I specified I wanted every minute. I wanted this, I wanted a minute iteration for this VPC flow log. So after a minute, it'll take a minute's worth of network content and build the flow logs, zip it up, throw it in the S3 bucket. Now what do I do? This is a problem. It's good information. There's no way I'm going to go click that file because I know that file's of interest. I am dropping in S3, so I could have some Lambda function, and that Lambda function might go and extract this data and identify all the SSH, but that's not really great for hunting because I want to be able to do stuff ad hoc. So going to S3 bucket is nice. It's great for automation, may not be great for our hunting. We're going to need another service. So I'm going to show you two ways in which we can do this. But before I do, I got to show you the last kind of data that we're going to look at, and that is application data. We looked at first our Amazon environment, and we're pulling all the API calls into CloudTrail. I then can look at network traffic going across the network interfaces. But I've got EC2s running, and those EC2s are generating lots of great logs. Lots of garbage logs probably too, but you're probably getting some great logs that you want access to. Or maybe there's other logs being created in the environment. Your Lambda functions are creating logs. You might want to see those. So Amazon has something called CloudWatch logs. They're bins of logs sent from, quote, applications. They could be almost anything. And they're dumped in a place that gives you some better tools to search and evaluate and trigger. Trigger's the big one. CloudWatch logs monitor, store, give you access to logs of different file formats. What you would do is you would create a log group, and you say this log group is Nginx logs, so Nginx connection logs. The format of those logs should all be very much the same, and you put that in one location. I can go get logs from someplace else. I can get place logs from my VPC flow logs. Remember, in the VPC flow logs, I said you can pick either S3 bucket or the VPC, S3 bucket or CloudWatch to store the data. Those are CloudWatch logs. So each one of those VPC lines would be in a CloudWatch log. CloudWatch has something called, and they do this to try and centralize the logs. So you can use this as your centralized logging environment. You might already have a centralized logging environment. You might have a tool that you purchased or using Elasticsearch or Splunk or one of the other cloud-based ones that you're using for centralized locational logs for evaluation. This is another way of doing it to use Amazon, okay? CloudWatch has something called metrics, which allows you to look at trends in data. So maybe I'm not interested in a single failure of SSH because if I have something on the internet, everyone's trying to SSH into it. But maybe I'm interested in 5 of those happening within a minute. So metrics will allow you to say, if I see this, raise the alert. If I see this many alerts in a certain amount of time, go and run some command, an SNS, a Lambda, whatever it is. There's also a tool called CloudWatch Agent, and that will run on a virtual machine and will snarf up logs and throw them at CloudWatch to put in your place. I'm going to show you a demo of how to do that. I have limitations. They're not great limitations, to be honest with you. There's limits. You have to limit the data. By default, your cloud logs stay around forever, and you have to actually delete them. And it's after a while, you're like, I have this CloudWatch log. I don't know what it's for. Do I delete it or not? I don't. You have to kind of think about that ahead of time. Or you can create your CloudWatch logs and you can say delete them in a day or 10 years. You have to keep in mind, how long do I want to keep it? How long do I want to keep it? If I have too little data, then maybe my hunters can't see what they need to see. If I have too much data, same problem. There's too much to go through. The hunters can't see what they can see. So you got to think about how you're going to limit it. You only get 5,000 log groups. I know it sounds like a lot, but you could use them up pretty quickly per account, per region, but that is a soft limit. You can go request more. Likely, if you have 5,000, you should be automatically creating log groups for very specific things, and it's all automated. If you've by hand created 5,000 log groups, then you're doing a lot of work. That's great, but it might be a little chaotic. All right, so let's go. Here it is. So let's look at OWASP top 10, and let's look at one specific of the top 10, and that's broken authentication. The idea that, all right, I'm going to look for application data on a host, and that host is going to be monitoring my my Nginx server, and my Nginx server can determine what URLs are being submitted to it, and it kind of stores that into a file. One thing an attacker will try to do is try and get around whatever the authorization or authentication methods are and try to get data it's not supposed to. And one way it does that is through something called path traversal. So you can see the example below on the screen, what it's doing. I'm going to my URL and I'm doing an item equals, and it's expecting some file, and it's going to go and grab maybe a text file and present it to you. But instead, I'm telling it to go up the directory stack and go and get my Etsy shadow, which will give me hashes of my passwords. We want to detect if someone's attempting to do this. We really want to detect if someone does it successfully. But the first thing is, can I even see that this is happening? Let's see. We're going to use CloudWatch to do that. We're going to use the CloudWatch agent. The CloudWatch agent is the newer version of what was called AWS logs. If you're an expert on this, in my demo, I use AWS logs because it's a little bit easier to set up. The CloudWatch agent does a lot more stuff. They will monitor logs and files and configurations and some other things that's happening on your environment and send that stuff to CloudWatch. And it uses Amazon's privilege model, the IAM privilege model, to give authorization. So the fact that you're able to send that, you get to control through IAM. You can collect data that's on EC2, or you can collect things on your on-prem device and get them both into the cloud. It does require your IAM access, and you can deploy the stuff manually, or you can use a system manager to do the deployment of the app, the CloudWatch agent or the AWS logs app. So what I'm going to show you in this is how we would use, well, I'm not going to show you how to install AWS logs because I didn't want to spend the time doing it in my hour. It's pretty easy. It's just there's already some notes online to how to do that. What I want to show you is the results that come in. Let's specifically look for the directory traversal from Nginx logs. All right. So I go to my CloudWatch logs. I see an Nginx. Oh, they're broken up by the interface or from the instance it came from, and I can do some basic text queries here. And one of them is .. so I can see it. Now, what you're looking at here is the log that CloudWatch does not understand the format of your log. Like, it's just a piece of text. It's a pretty well formatted message, and that message, you can see that is text right here, and it's well formatted, so you could extract it out, but for right, it doesn't know what to do. But you can do a search across it, so you can do a query search across that thing and look for certain queries. So that's nice. The nice thing also you can do is you can use things like metrics, and you can use something called Cloud Insights to maybe query it a little bit better. I'll show you that just one second. But first, let's look at our VPC flow logs. So remember I said the VPC flow logs could be sent to your S3 or to your CloudWatch. In this particular case, I'm going to send it to my send it to CloudWatch. So you can see here when you create your VPC flow logs, you set your destination log group, VPC flow logs. That's what I named it. It's not a very exciting name. So I'm going to click into it. Let me show you how to do it from CloudWatch. So from CloudWatch, you go to log groups. There's my flow logs. Those are Lambda ones. So every time I deployed a new Lambda version, it actually shows up automatically in there. So, and you see never expires. So those things could be there for a long time. So that's why your 5,000 can really rank up. All right, now it's being split by the ENI. Oh, and now look at this. If you remember, those are individual flow logs, right? And I have the same ability to do basic querying of those flow logs like I did before. But again, the way it's shown here, it doesn't know the format of those flow logs. They're all the same format. They're well formed, but he does. CloudWatch does not know at this point. So I got to do something different. Oh, and the other thing to mention is that in the S3 bucket, it was capturing the data and it was dumping into a CSV file. And you have to look at that CSV file as a group. So everything happened over that minute. In CloudWatch, I get each individual flow log entries one at a time, which means I could have SNS trigger off of this. I can use other things to trigger off individual ones. So that's nice. All right. So I'm going to use pull up something called CloudWatch Insights, which I'm not going to spend a whole lot of time on it, but this gives you a little bit better querying and visualization of what's happening inside of your logs. And you can see I used a query up at the top. I just used the one that was on standard, and there's a little bit of a display. If you've got Splunk or Elasticsearch with a nice Kibana or Grafana, whatever you're running in your cloud environment, you got a better GUI, right, than this, but this comes with it. I also have something called metric filters, which I mentioned before. The idea is that if I have one SSH, maybe I don't care about it, right? Single SSH. But maybe I have 5 of them in a row and they're all within a minute. Maybe I do care at that point. And a metric, I say, hey, go look at everything in the VPC flow logs as they come in. I give it a filter pattern. Ooh, that filter pattern now describes the format of that VPC flow log. And it can use that to extract out, if destination port is 22, throw an alert, or run an SNS, or go hit a Lambda function, or a step function, even better. So I can use this to start evaluating my logs, evaluating the data that's in the logs, assuming I understand the pattern, and then alerting on it, which is great. Now I have some automated response action. But it still doesn't get me the ability to query this stuff. So I got to use something else. And so Amazon has something called Athena. Athena is a SQL query service that allows you to query data against S3 data. And there's actually other services you can do besides just S3 data. I've done the S3 queries pretty extensively lately, and I love it. I love the fact that I can say, hey, here's my S3 bucket. Here's the format of the data that's in this part of the S3 bucket. So in my VPC flow logs, remember it was the CSVs and they were all they were gzipped up. I can point Athena to that location. I can say this is the structure. It actually understands the structure because of the CSV headers. It knows the names of the data. And then I can do things like partition the data. So I can say, hey, partition data by every hour, or by day, or by month, or by year. Or actually, I can't, not and, but and. I can and all those together. And then I can query that data and say, hey, over the last hour or the last year, what are all the SSH attacks or SSH commands? Some limitations. It can be slow if you have lots of data, and you could have lots of data. If you're running for a year and you've got terabytes of data, and you say, hey, look across this whole terabyte of data, it's going to take a long time for you to run it, and it could get expensive. So it's great for ad hoc. It's great for smaller data sets, But if you get into a bigger data and you want to run something over and over again, there are other tools that you could use in Amazon to be able to do that. But Athena is great for ad hoc. So let's look at how we use Athena. So in Athena, there we go. So right here, what I've got is I've got a command that says, I want you to create a table. Now, if you have some database experience, this should be similar to you. I want to create a table called VPC_flow_logs. The location, which is right here. I'm not sure. Hopefully, you can see my pointer. My location here is this S3 bucket. That's called S3_bucket. It's obviously a fake name, but that is where all this data is. And actually, it'll use that prefix to find it. And says this is the elements I really want: version, account, interface ID, number of bytes, start time, end time, login. And I want to create a table with this information. Because if you're doing a SQL query, you need a table. All right. So now I've got my table. And you can see on the left-hand side, I've got a couple tables as I was building this for the demo here. And I'm going to run a SQL command, select star from the table, VPC_flow_logs, where my destination port is 22, SSH. Only bring back the last 10 because I want to be quick. So I'm going to run this command. It came back. And now I've got a table at the bottom with the data. Oh, and the data is parsed. So it understands the different data elements inside those VPC flow logs. And it's going to give me things like destination and source address. And you can see there's some repeat sources in there. That's interesting. I'm just getting everything I could have just pulled out before, but I can actually run commands across this. I can say, give me the source address, and what I want you to do, let me get the right one in there. See, it takes a second, which is a small amount of data. I only had a small amount of data for this, and it took a second. So imagine if you had terabytes of data, it might take a long time. I want you to go and select just the source address, and I want you to create a total. And I want you to group it by source address. So basically what it's saying is get all that data that you told to get, group the source addresses that were together, and count them, and only give me the source address and the count. Why am I interested in this? Ooh, maybe I want to see the source address that's brute forcing me, which means they probably have the most SSH connections. And so I can use this query right here to say, oh, this guy right here, 37.49, whoever it is, they try to SSH 12 times. That's not a lot for a brute force, but if that's 50, it's 25. I don't know what brute force means to you. That's kind of one of the problems with this threat hunting. You have to have your kind of, what do I care about? But you can go and you can look at this data. What's really nice is that I can not just use the GUI to do this querying, I can actually run this through the AWS CLI. So if I have predetermined queries, or I want to take the results of these queries and push it to another, like, JQ or Python or something else, I can do that interactively through scripts. Now, if you're running the same query over and over again, Athena is probably not the cheapest way for you to do it. Athena uses data catalog and AWS Glue to go into each of those files, extract them, do stuff. So that's kind of what it's using under the hood. There might be cheaper and faster ways of you doing repetitive stuff. But if you're doing ad hoc querying, I feel like this is like one of the best tools that Amazon has to be able to do that. All right. We're kind of running out of time. If you have any questions, definitely put them in the question section of the web software, and I'll answer those when I'm done with just a couple more slides. All right. One thing I do want to kind of end the talk on is the idea of how do I need to architect my environment to support hunting. Now, we don't have time to actually give you specifics of every specific thing you should do, but this is kind of a general conversation of what you need to think about. Your threat hunters need the right data, and they need it in the right place, formatted properly. So you need to have, if you need to be able to look at network traffic, they need to have VPC flow logs already going. If you're not going to look at your network traffic across all your systems, but you only want to do it on the sensitive systems, then have the VPC flow logs just for that sensitive systems. That really lowers the garbage that your threat hunters have to look at. You need to think about ahead of time how long you want to keep that data. If you have a threat hunter and it's Frank, and Frank only does threat hunting on Mondays, then you definitely need more than a week's worth of data, or they're going to miss something. And think about they go on vacation for a couple weeks, right? Now they've missed weeks because you're deleting it every week. So you got to think about how long to keep it so that it's in a place that's useful. The big thing, which I think is the next two things, kind of I would roll them into the biggest problem. One of the problems when I talk to people who are starting to do this threat hunting in their environment is they don't always have good access to data. They don't know the infrastructure really well. It's difficult when I hear that happening, where an organization maybe is so big that whoever's doing the log analysis don't actually know what the architecture looks like. So it's hard to determine what weird looks like, right? If you just look at logs of network traffic, a lot of things could look weird that are normal. If you live in an environment where you are allowing humans to do SSH from place to place and run commands on EC2s, then you're not going to know that a list bucket was done by an attacker. You're not going to know that there's a bunch of SSH failures that is a brute force attack, a slow brute force attack. Those are possible. It might just be somebody doing their normal job. So if your daily activity looks like a higher risk activity or looks like an attack, then you got to change the way you operate your environment, not ignore what's happening. And one of the best ways to do that is to leverage infrastructure as code. If you can have CloudFormation or Terraform running on a dedicated system, do your deployments and do your updates, then you don't need to have SSH unless you're troubleshooting, which is a very unique case, but not all the time. You don't need to do updates. You don't need to do a lot of stuff. You can significantly reduce the policies for those EC2s, and you'll be able to see more failure attempts, right? If you open S3 buckets to everybody, then someone's going to get access to it, and they're going to see in your S3 bucket. So use things like infrastructure as code and proper architecture to make sure that the attack techniques that you're looking for are obvious. And the last thing I would say is run attacks inside of your environment. Make sure that you are simulating it so that your threat hunters know what to look for and they can detect it. You can do this where they don't know that you're running the attacks, that is fine, or they know you're going to run the attacks and you look at it. Or maybe they run the attacks, that's always really nice. And they can see the product of what it looks like. So they know that their tools are proper, they've got the right data in the right place. All right. So that is it for the talk. I just want to highlight, these are the classes that SANS has now, or in my particular case, coming out very soon, that are really focused on security in cloud environments. So a couple of years ago, we had a couple classes, and now we have 11 that are here or coming out soon. I teach the 545, which is near the bottom of the middle, and I'm writing the security 541, but any of these classes are really fantastic. So if you want to take your training to the next level, take a look at what SANS has to offer. And that is it for me. And let's see if there's any questions. I have a couple questions about if the slide decks will be available. Yes, the slides and the recording will be available. I think actually, I'm not sure how they get them. I think there's an email. You can go and download it. So there's one question about, let's see. Let me make sure you get it right. Touch on integrating the tools you talked about with security. Oh, security guard duty. Thank you, Robert. I actually was going to mention that, but I was checking my time. I was thinking about doing whole pages and had to cut it out. Security guard duty and Security Hub are Amazon's managed services that are trying to evaluate the data that they have access to, which is the data I just showed you, and try and detect things that look like they're bad. So they're starting to help do the work for you. Guard Duty and Security Hub both have the ability to integrate with other tools. So maybe if you see a Guard Duty alert, it can go and you can have it trigger something else and run something. So those are really nice. You do need to make sure you know what your limitations of Guard Duty. They will only detect the things that they are detecting. And so if you decide to run Guard Duty, you can go and look at all the Guard Duty things that they detect. You go back to your MITRE ATT&CK framework and you say, I don't have to care about that anymore because Guard Duty is detecting it. And you can go and look for all the stuff that Guard Duty does not do. Or these managed services, when you get them out of the box, I tend to find that they look for things they're pretty confident, but if they have a lot of false positives, you won't use it. I know with guard duty, some organizations do get quite a bit of false positives, and they have to tune it. If when we do 541, we'll actually go into details about how guard duty and security hub and possibly detective works, and how you would use it, and how you would kind of do that, right? Try and reduce those false positives. So thank you for that question, Robert. You reminded me of what I missed. How to hunt for web shells and web applications hosted on AWS. So the hunting for that kind of stuff is very similar to how you'd be hunting it in your virtual machine. If you have tools that are looking for new processes being loaded on your environment, you could use those tools probably in AWS. Amazon also has things like Inspector and AWS Config, which will do an evaluation of what applications are running on your instance. And you can use those tools to go and look for, do I have a binary that's not supposed to be there? And you can use those kind of tools. They'll take their data, they'll give it back to AWS, and you can integrate that. It will show up as another CloudWatch log for both of those tools. So I don't have a list of useful SIEMs to do this. Sorry, SIEMs. I always go back and forth. And use cases. There is a what I would recommend you do, if you're looking at just for the data. I don't want to say one product's better than the other. I personally have used Elasticsearch, and we write our own detections in there. I know people have used Splunk, and then there's some other ones that kind of can do that. A lot of those times, they're trying to give you a better way of analyzing the data. What we show with Athena might actually be cheaper to use those tools. In the long run, I don't know. It depends. I don't know how much you paid for your SIM, but that CloudWatch data can be ingested. What I like to use, I like to go to Rhino Security and some of the other companies that are building tools to do pen testing, and I like to use those to say, all right, what is the attack? I'll run the attack. I'll look and see what logs should be able to pull. The Cloud Matrix from MITRE does not get into specifics that say, if you want to do brute force, you need to pull VPC flow logs. I wish they had that, and I've never seen a one-to-one documentation of that that's published really well. We hope to do that some in 541. And there's a question about when it'll be out. 541 hopefully will be out in fourth quarter, so that's between October and December. It'll be a one-day class to start, and it'll be very much focused on AWS. So, all right. I think that's it on the questions. And I will turn it back over to Carol.
All right, thank you so much, Shaun, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.